Hi everyone, this video is going to look at some more SAT math questions that focus on our understanding of basic operations with fractions. So that includes adding, subtracting, multiplying, dividing fractions. These questions, however, are going to be a little bit more difficult because going beyond the basic concepts, they're going to ask us to apply a little bit of logic or critical thinking. So let's take a look at the first problem here, number 7. I see off the bat that I have two fractions that are being set equal to each other. And if you remember from our previous video about how to operate with fractions, when two fractions are equal, we want to cross multiply. So I'm going to go ahead and rewrite this equation as 7 times a minus b equals 3b. And then I'm going to distribute, so I get 7a minus 7b equals 3b. At this point, a good rule of thumb is always combine like terms whenever we can. And many of you have probably heard that before, combine like terms, but what does that really mean? Well, usually it means that if the variables are the same, you can add or subtract them. So for example, x plus 2x equals 3x. And if I say something like 2y minus 5y, that equals negative 3y. Now you do want to be careful because not only do the letters need to be the same, but also the exponents need to be the same. So x plus x squared does not equal 2x squared or something like that. So make sure you check the exponents because if they're not the same, you can't add or subtract them. But here we see two terms that both have b involved. So I'm going to go ahead and add 7b to both sides. And that'll give me 7a equals 10b. Now this is where the critical thinking comes in because the problem doesn't ask us to solve for a or b actually. Instead, it asks us which one of the following answer choices is true. And by true, they mean is equivalent to the equation that we just derived. So I'm going to go ahead and take a look down my answer choices, and I'll notice that the first two answers both have a divided by b. Further down, I see a plus b over b and a minus 2b over b. But I'm going to focus on the most common setup, which is a divided by b. So I'm going to divide both sides by b. And then I'll get my 7a over b equals 10. Now, to fully isolate this, I want to divide both sides by 7. So that will cancel out that 7. And then I get a divided by b equals 10 over 7. Answer choice B. Moving on to the next one, number 8 here, we see we have two fractions with binomials or algebraic expressions in the denominators, but they're being added. So I'm going to start with those two. I'll come back to the numerator later, but I'm going to start by saying 1 over x plus 2 plus 1 over x plus 3. And remembering that when I add and subtract fractions, I need to have an LCD, or a least common denominator. And the easiest way to get an LCD is simply to multiply your two denominators together. So I'm going to multiply my fraction on the left by x plus 3. And whatever I do to the denominator, I have to do to my numerator. And the fraction on the right, I'm going to multiply by x plus 2. And same idea, whatever I do to my denominator, I have to do to my numerator. Now, we're going to do a little bit of foiling here. So I'll do this off to the side. X plus 2 times x plus 3, that will give me x squared plus 3x plus 2x plus 6. Combining like terms gives me x squared plus 5x plus 6. Now that's going to be my shared denominator, x squared plus 5x plus 6. Then my numerator, I just combine these two fractions because anything times 1 is just itself. So I'll get x plus 3 plus x plus 2. Again, combining like terms, I get x plus 2 plus 5, 2x plus 5 over x squared plus 5x plus 6. Now what we've done here is added two rational expressions. That's the term for these algebra fractions. They're called rational expressions, and we've added them correctly by finding an LCD. But we have one more step, which is this 1 in the numerator. Now the easiest way to solve this is simply just recognize that when you have a fraction in your denominator, right, what you're really doing is you're saying, I'm going to divide by this fraction. And when you divide by a fraction, remember from our other video, it's the same as multiplying by the reciprocal, aka just flip it. So I'm going to do the same thing here. Because it's going to be 1 divided by a fraction, I can go ahead and change that multiplication, change that division to multiplication, and then just flip it. So my final answer will be x squared plus 5x plus 6 all over 2x plus 5. Answer choice B again. Next question. Now, here we're getting into some high-level math because we have this idea of I. And I, some of you may have heard before, stands for an imaginary number because you can't actually take the square root of a negative number. It's impossible. But what I does allow us to do is to state that I squared equals negative 1. And we're going to actually use this understanding to substitute later in down the line. But the main idea here that we want to take away for the SAT is that when we see I, we want to always multiply the denominator by its conjugate. Now, some of you may wonder, what is a conjugate? Okay, a conjugate is actually a really easy concept. If I look at my denominator and I have 8 plus 2i, the conjugate, here I'll do this in blue, is simply going to be the same terms, 8 and 2i, but I change the sign from a plus to a minus. So the conjugate of 8 plus 2i is 8 minus 2i. So I'm going to go ahead and take this information. I'm just going to do the math here on the side. I'm going to have 3 minus 5i divided by 8 plus 2i. And because I see these i's, I know I'm going to multiply the denominator by its conjugate. So this will be times 8 minus 2i. And just like with all these fraction problems, whatever I do to the denominator, I have to do the numerator. Whatever you do on bottom, you have to do on top. So now we have two FOIL problems. In the numerator, I'm going to draw the arrows here because this looks a little bit tricky. My first term is going to be 24. My outside terms are going to multiply together to be negative 6i. My inside terms are going to be negative 40i. And my last terms are going to be plus 10i squared. In my denominator, same foiling method. First, outer, inner, last. I'll get 64 minus 16i plus 16i minus 4i squared. Now I'll go ahead and combine my like terms. Actually, sorry, before I do that, I'm going to go ahead and use my substitution. I squared equals negative 1. So I'm going to go ahead and replace both of these I squares with negative 1, which will change these terms to negative 10 instead of positive 10 and plus 4 instead of minus 4. And now I'll combine like terms because I'll have 24 minus 10 minus 6i minus 40i all over 64 plus 4 minus 16i plus 16i. And so minus 16i plus 16i cancel out. In my numerator, I will have 14 minus 46i. My denominator, I will have 68. Now, taking a look at my answer choices, again, these questions get harder because you might have to use the answer choices to guide you. You notice that they split all these fractions down the middle, right? They have your normal fractions on the left, and then you have all your I fractions on the right. So I'm going to do the same thing with my fraction. I'm going to split down the middle and make it 14 over 68 minus 46i over 68. Now I can take a 2 out of all these terms, so that'll reduce down to 7 over 34 minus 23i over 34. Now remember, you can't do anything with I. I has to just stay the way it is. So if I look at my answer and I compare it to my answer choices, I see that I get C. All right, our last problem here, also a tricky one. I'm going to erase some of that previous work just so we have plenty of space. This is, again, involving I, right, which can seem intimidating at first, but with a little bit of practice, you can definitely get very comfortable with it. I see I and I see a denominator, so I'm going to multiply by the conjugate. And remembering that the conjugate is just the same expression, the same equation, except instead of 3 minus 2i, which was in my denominator, I'm going to multiply by 3 plus 2i. And now I'm just copying the original problem back down. And whatever I multiply my denominator by, I have to multiply into my numerator. This means some foiling again. First, outer, inner, last. So this will give me 24 plus 16i minus 3i minus 2i squared. And my denominator, 9 plus 6i minus 6i minus 4i squared. Now, if you do a bunch of these conjugate problems, you'll notice that the middle terms in your denominator always cancel out. And that's actually the goal. That's a nice little safety net that we can use to just double check our work and make sure that we're doing the problem correctly. So now I'm going to go ahead, I combine my like terms to get positive 13i, and then I also replaced I squared with negative 1 in my last term. And I'll do that on the denominator too. I will do 9 minus 4 times negative 1. Negative 2 times negative 1 becomes positive 2, so I have 24 plus 2, that gives me 26. 13i stays the same, and then negative 4 times negative 1 gives me positive 4, so that's going to be 9 plus 4, which will give me 13. Now, the reason this is considered a tough problem is because, again, they're not asking us to solve for I. You can't, right? I doesn't have a value other than square root of negative 1, which is imaginary. What they want us to do is find the value of A. Now, where does A come from? Well, that's this statement A plus BI. So this is the answer that we got, which is correct, but I need to make it look like A plus BI. And so what that means is, once again, splitting up my fraction so that I have one fraction that's just regular numbers, constants, and one that has the I attached to it or multiplied to it. So here I do that, and I notice, oh, these will cancel out pretty nicely, 13 over 13, and 26 divided by 13 just happens to be 1. So the simplified version of 26 over 13 plus 13 over 13i is simply 2 plus I. And if I follow my formatting here, that means that A is equal to 2, and B is actually equal to 1. It's not written there because anything times 1 is itself. We don't write the ones when we're multiplying, but B does equal 1, and in terms of the question, A equals 2.